Welcome everyone to Wes Explains Best. Today we're going to be talking about rationalizing the denominator. We're doing a Kuta software worksheet. These worksheets are common for teachers to give and supplement of what they're doing. I generally assign the odd problem, so we'll go ahead and start with the evens. So when we're looking at problems like this and we're asked to rationalize the denominator, essentially what we need to do is we need to rewrite this into an equivalent expression that does not have a square root in the denominator. So how do we do that? Well, the trick is we can multiply this by 1, this expression by 1, and it doesn't change the value of the problem at all. So what happens if we multiply it by 1 over 1? Same deal. It stays exactly the same. The value does not change. What happens if we multiply it by 2 over 2? Well, this is still equal to 1, so we can do that, but it's going to change how it looks. 2 radical 3, 2 radical 6. It's still the same value. It just looks different. So that's our goal here, is we're going to try to make it look different, even though the value is still equal to 1. So what should we put? Well, in place of a 1, what we need to do is we need to think of something that we can get rid of this square root. How do we get rid of that square root? Well, we need to multiply it by its square root. Multiplying a square root by its identical square root essentially undoes the square root. It's the opposite operation when you multiply it by itself, because you get 6 squared underneath and then square root. The square root is undone by the squared and it just becomes 6. So that's the whole premise, is getting rid of the square root is as simple as multiplying by the square root of 6 to get rid of it, okay? But what you multiply to the bottom, you have to do to the top. So in the top, we are going to get the square root of 18. We already said in the bottom we're going to get the square root of 6 squared, which, in case you didn't know, it's the square root of 36, which is equal to 6. So we get 6 in the bottom there. In the top, we have square root of 18. Now, we need to simplify the square root of 18. So what I like to do is I like to do a factor tree. I have many videos on doing this, but I always don't mind giving a quick recap. So I like going to the factor tree method. I factor this into its prime factors. As you can see, these are all prime factors. And I'm looking for anywhere where I see 2 of the same prime factor, in this case 3. The reason why this works is because 9 is a perfect square, okay? So anytime you see 2 identical factors and square roots, one of these is going to leave the radical, one is going to stay inside the radical. I like to say, if you have a date, you get to leave the house, but if not, you have to stay home. So what does that look like? That means 1, 3 will leave the house, the 2 will stay home, and that is the simplified form. So we have 3 radical 2. Once we get here, we always want to check to see if we can reduce the coefficients or anything else. So we're going to cancel the 3 with the 6, and we're left with 2 in the bottom, radical 2 over 2, final answer. All right, let's scroll down to another problem. Let's do number 4, and then we'll skip to number 8 after that. Number 8 is a little bit different. So hopefully you guys can recognize now that we need to get rid of this radical 5. In order to do so, we have to multiply it by radical 5 to the top and bottom. We are not concerned, by the way, with anything that's in the top. If there's a radical or any other number in the top, that's fine. It's only in the denominator we cannot have a radical. So we multiply the top times the top, radical 5, and then radical 5 times radical 5 is going to give us 5. Just in case you're not following that, radical 5 times radical 5 equals the radical of 25, 5 squared, and that's equal to 5. So now we cancel here at this stage, so we can cancel the 5 with the 5 completely. You're left with square root of 5 over 1, or just radical 5, and that's our answer. So all these problems, 1 through 6, it looks like, are all similar to that one. Now, let's get into something a little bit more difficult. So here we have a problem 2 over radical 5 minus 5. Your first temptation is probably to multiply radical 5 over radical 5, but this does you no good because you have to distribute to both terms inside the radical. You'd have to multiply by the negative 5, and the radical 5. If you multiply it by the radical 5, you get 5, but then if you multiply it by 5, you're going to get 5 radical 5. So then you would still have a radical in the denominator. So this process is no good. We need to come up with something else. Let me erase. I should have let you pause. Go back and pause that if you want to take a... No, there we go. So go ahead and pause this and see why it doesn't work. Okay, it's a very common mistake. All right, now I'm going to erase it. There we go. Okay, so what we're going to do instead is we're going to multiply the top and bottom by the conjugate of the denominator. I know you're thinking, conjugate what? Well, a conjugate is essentially something that makes it into difference of squares. So the principle of difference of squares is that if we have two binomials, and this problem is a binomial, there's two terms in the denominator, and they're identical except for one has a minus and one has a plus in between the two terms, then essentially the middle term will get canceled out after you FOIL. If you remember FOIL, we do first, outside, inside, last when you multiply. So what we get is x squared minus xy plus xy minus y squared. Notice how the two middle terms get canceled out and we're just left with x squared minus y squared. Now would be a good time to pause if you need to copy that down because I'm about to erase. Okay, so we're going to use that principle. And how we use it, let me shrink wrap this real quick. Shrink, move it over there in case you need to reference it. What we're going to do is we're going to copy this binomial down, the same one we see there, but instead of a minus sign, we're going to put a plus. And we do the same to the top as we do to the bottom. How does this work? Well, after we FOIL, this is what it's going to look like. So let me take my time in FOILing this so you guys can follow along on why I do this. So we're going to do square root of 5 times square root of 5. That gives me 5. We're going to do square root of 5 times 5. That gives me 5 radical 5. So we still have some radicals, and that's not good, but hopefully that will get taken care of. Then we have negative 5 times radical 5. That's negative 5 radical 5. Negative 5 times 5. That's negative 25. What do you notice? Well, the middle terms cancel out as promised, and then we're left with 5 minus 25, which equals negative 20. So as you can see, by multiplying by the conjugate, we're able to get rid of the radicals in the bottom, and now it's negative 20. Now you're probably thinking, oh, but there's radicals in the top. It doesn't really matter. We can have radicals in the top. It's no problem. So we can distribute the 2 to both the radical 5 and the 5. We get 2 radical 5 plus 10. Actually, in this case, I'm going to show you why. I'm going to leave it as 2 parentheses radical 5 plus 5. I would recommend not distributing until you check to see if you can cancel. So in this case, you can cancel. So we are going to cancel the 2 with the negative 20, and then we're left with negative 10 in the bottom. So then we have radical 5 plus 5 over negative 10, final answer. And that's a simplified form. Okay, we're going to do one more. 14 is going to be doozy, a long one. So we're not going to, we're not going to do that one. It's just keep in mind you're going to have to FOIL here. So this one you're going to have 2 terms and you're going to have to FOIL and multiply. That's just a heads up, okay? But let's go ahead and do number 12 together. I suppose, good as any. So again, we need to multiply by the conjugate. Just multiplying by radical 3 will not do you any good. So we need to multiply by 2 minus radical 3. That's the conjugate. And the reason why I know I need to multiply by a conjugate is because we have a binomial in the bottom. 2 minus radical 3. Okay, I'm going to do this quickly here. Try to follow along as best you can. We do first terms times each other. We get 4. We get minus 2 radical 3 plus 2 radical 3. And then minus radical 9. As you can see, you're going to stop. Eventually, you're going to learn that you don't multiply the inside and the outside terms together because they're always going to cancel anyway. So really, you're just going to do the first and the last terms times each other with conjugates. That's the whole point. So we get 4 minus radical 9 is 3 equals 1. That's pretty cool. We get a denominator of 1. Then we get 4, 2 minus radical 3. I guess in this case, we could distribute, and we get 8 minus 4 radical 3 as our final answer. Hope you guys found this video helpful. Hope you see you next time in the next video. Until then, be good, be kind, be true, be nice, and be honest, and have a wonderful day.